Hi and welcome to the first lesson video tutorial. As requested, we are starting with ECN 329 and hopefully we can cover a lot. We've had requests for 329 and 328, so hopefully we can cover both. So we're starting with module 1, so we didn't get a specific module, so we'll do like the calculations for as many modules as we can, and then we'll probably just do past questions. So today's video is module 1, NESA video tutorial. And so module 1 is scheduling and sequencing, and what we're going to actually be doing is the calculation questions. And if you don't have assignment 2, which was one of the assignments they gave us during the period of the semester, the online semester, then you should probably download it from the Moodle because it should still be there. I think it was the second assignment, so download it from the Moodle. We're going to be using that. Those are the questions we're going to be solving. A little backstory on sequencing and scheduling, or scheduling and sequencing. Scheduling has to do with establishing a plan of how you're going to use the time, or of the timing of use of various resources available to an organization. So you have its facilities, its equipment, and its human activity. You're scheduling the use of time of each of these for each of these things that an organization has, and that's the basic gist of it. So with scheduling, what you're trying to do is efficiently give everything, okay, this is a time. Then sequencing now orders what you've done. So you've told that, okay, this is how much time each job is going to use in this work center, but you've not said the sequence in which jobs should be performed by what job centers. And that is where sequencing, sorry, that's where sequencing comes in. It gives order to what you've already scheduled. So we'll see as we go. The sequencing part should be familiar to us. We'll still touch on it because it has to do with the assignment model, which is the way in which we are going to be calculating it, but that's something that we've done before. So I would advise that you read the slides for this particular topic. I couldn't find it in the textbook that I use, which I will link or upload or something, link down below, a Google Drive link for you to download the textbook that I use. But this particular topic, the slide was more than sufficient to explain the wordy part. So this is already 2 minutes. You can just skip past. I'll put timestamps in the description. Moving on, so today what things that are going to be helping us are our formulas. So I just want to bring them to our notice. So these are the formulas that we're going to be leveraging today. We have 5 formulas, and I think if you can get these formulas down and even understand them. So very quickly, you want to know the average flow time of each task. That's like how long does it take to do one task, right? So to know, you take the total flow time of all the tasks divided by, this is what I'm explaining, divided by the total number of jobs. So the total flow time of all the jobs divided by the total number of jobs will give you the average flow time of one job. The second is the average number of jobs in the system. So you know the total flow time, you know how long it takes to process each job. So if you know that, okay, we have 300 minutes in flow time and it takes 60 minutes to process each job, it tells you how many jobs you actually are processing in the system. So that's the average number of jobs in the system. Number 3 gives us the average job lateness. That's how many jobs are you late on? Are you past the due date? So total late days divided by number of jobs. That's basically it. So we've been in total on all the jobs we are 30 days late. Divided by the number of jobs, it gives you how many days late you are for each job. So that's this formula here, and this formula here basically tells us the total late days. So because you need that total late days in formula 3, you have to calculate it in formula 4, and basically you just look at the flow time for each job and deduct the due date, and you add what you get for each of the jobs, and so that gives you your total late days. And so one thing to note in formula 4 is whenever your answer for flow time minus due date is negative, you just put a 0 there. There is no need to add negative figures. Then formulas. So for number 5, which is formula 5, which says utilization of work center, I want to know how well the work center is being utilized. So we're going to take total processing time divided by total flow time. Sorry, there should be an E here. Divided by total flow time. That means how long does it actually take you to process things versus how long they spend or flowing through the system. That's my understanding of it. So, and once you get that, it's telling you you use 0.4, you use, let's say, 1/4. That means for every, let's skip over that part. Basically the explanation is efficient, but you have to times it by 100 to get an actual percentage of how well you're utilizing your work center. So this total flow time can even be seen as like the work center capacity, and processing time is how much of it you are using. So these will be helpful for us throughout. We'll be referring to them throughout this assessment. So we're going to get on with solving the question now, and I'm going to start. Okay. So the first thing that you want to do is to establish your table. Inside that table, we're going to calculate our flow time. So as you can see in the question, flow time itself is not given. So you have to actually calculate your flow time. So we're going to make a table of the table that is given, and we're going to leave the space for flow time. Need a ruler here. So this part is not nitty-gritty. We're basically recreating the table. The only thing we're adding to the table from the question is our total flow time. And so let's go. So you have let's dedicate here. All right. So jobs, processing time in weeks. So the unit of measurement for our time for this particular question is weeks. So here is where we're going to leave a space, just because it's more convenient to have your flow time right beside your processing time, because it helps with the calculation of your flow time. And then we have we're going to leave this space blank. So what I'm going to do now is populate this from data in the table. So this data is given in the question, so it's not brand new. Alright, so now that we've duplicated the table from the question, what we have to add to this table is the flow time. Because if we can tell from our formulas that we are going to be using, I feel like I should stick these somewhere. So if you can tell from our formula, one thing that is really important is the flow time, and it's not given in the question. You actually have to bring out the flow time by yourself, and it's not difficult actually. I don't know if you remember statistics and what they call cumulative frequency. So if processing time was the frequency, you would get the cumulative frequency by adding each number to the next one. So that's just the same thing for flow time, right? So flow time here is going to be, of course, 6. The next flow time is going to be 6 plus 9, 15. The next flow time is going to be 15 plus 13, 28. The next flow time will be 28 plus 15, which gives you 43, right? 43 plus 8, you have 51. 51 plus 17, 68. 68 plus 20, 88. 88 plus 22 will give you 110. And so if you want to really check how correct your flow time is, your last flow time should be equal to the sum of your processing time. And the sum of our processing time is 110. You can pause the video and go ahead and check that on a calculator if you are a bit lost. So again, your flow time goes 6 plus 9, 15. 15 plus 13, 28. 28 plus 15, 43. 43 plus 8, 51. 51 plus 17, 68. 68 plus 20, 88. 88 plus 22, 110. So because we know we're going to be working with the summation, we are just going to sum it up. And the sum of our flow time here gives us 409. And the due date summed up is 133. So now this is where the rest of the question becomes really important, because based on what you're doing, your arrangement and your flow time will change. So here I'm assuming that we're answering question 1, right? Question 1 says first come, first serve. So we're going to take our table aside for a minute and we're going to discuss something new. So you have what is called FCFS, first come, first serve. You have what is called SPT, shortest processing time. You have what is called EDD, expected due dates, and you have what is called LPT, longest processing time. These are called priority rules. And so if you had a factory and you were trying to decide in what way you were going to do the jobs, for you to adequately calculate your flow time and all these things, you need to know the way you are going to stack it up. Like, how do we take the jobs, right? And so first come, first serve says the first job that comes should be attended to first. So the order of first come, first serve for this question, which we have jobs A to H, would be A, B, C, D, E, F, G, H, which we already have in our table. So this table is sufficient to answer first come, first serve. Now, shortest processing time is different in that it arranges the jobs and the entire table based on the job with the shortest processing time. And so we can go back to our original table and see that the processing times are different. And so the shortest processing time happens to be A, followed by E, and then B. So the arrangement would now go A, B, A, E, B. So we're arranging it based on the shortest processing time, and you can see that the shortest one is A with six weeks, followed by E with 8 weeks, then B with 9 weeks. What's the next shortest? C with 13 weeks, D with 15, F with 17. So you have C, D, F. So we're going C, D, F. And then next you have G with 20 and H with 22. So G, H. So you can see that we've already changed the arrangement based on which one has the shortest processing time. It just means you want to deal with the ones with the shortest processing time first. That is what SPT is. So I'm going to just write it here. Shortest processing. That's what I'm writing there. It's my bad handwriting, but it's all right. FCFS, first come, first serve. That's what FCFS is. Earliest. And I feel these things are quite, sorry about my handwriting, these things are quite self-explanatory. Longest processing time. So at this point, what it means is that for EDD, we are looking at the one with the earliest due date should come first. And so I just to put it out there, you're going to draw a table for each arrangement. FCFS is the table we've drawn because we drew it in the order of the first job to the last job. We still need to draw a table for A, E, B, C, D, F, G, H, right? So this table is for first come, first serve. We need to draw that same table, but with the arrangements different, because whatever the question requires, whatever arrangement the question requires is what you want to use. And in this question, they asked us to use everyone separately. And so let's go into earliest due date. Earliest due date means the one with the earliest due date goes first. It's really just what they said. And you can see the due date. Earliest due date is the one with the shortest due date in weeks. And so you have C with 6, and you have D with 9, followed by A with 10, and so then it will be followed by H with 12. You just look for the one with the shortest due date in weeks, and then that is how we are going to arrange the whole thing. And so if you would allow me to rearrange it, so I do have to make a correction. This is not earliest, this is expected. But the condition is still the same. The one with the earliest due date comes first. And so from our table, from our question, you can see that the ones with the earliest due date are arranged as thus: C, D, A, H, B, E, F, G. And so the same goes for longest processing time. You want to see what has the longest processing time. And so when you look at it, the one with the longest processing time is H with 22. So H will come first, followed by G, which has the next longest. So that's just how longest processing time goes. The ones with the longest processing time come first. And so you'll just have to rearrange your table to H, G, F, D, C, B, E, F, E, A. And so once you know this arrangement, you're going to make tables for each of these arrangements. And when you do make a table for each of these arrangements, once this changes, everything that came with it will change. So when we do redraw this table, it's going to be digital, because to redraw it again with my hand is not exactly time conscious or time friendly. So I will redraw it, but you'll see. So let's go for so this is question FCFS. So that is what this table is. And so the first thing that we were asked to calculate is the average flow time. So I'm going to 1 and so we already have our formula here that tells us it's the sum total of the total flow time and divided by total number of jobs. So sigma total flow time all over total number of jobs. All right, so we're gonna go here. What is our total flow time? And what is our total number of jobs? Our total flow time is 409. Our total flow time is 409, and our total number of jobs is 8. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 jobs, and 409 is the flow time. So we'll have 409 divided by 8, which would give us 51.125. That's the answer to that question. The next thing we're asked to calculate is the average number of jobs in the system. And so the average number of jobs in the system, from our formulas that we have, we can see that the formula goes sum of total flow time divided by total processing time. You can go back to the beginning of the video for the explanation, but sum of total, I didn't need to write the word sum again. This stands for summation, so there was no need. Total flow time all over total processing time. Mind my horrible handwriting. So let's go back to our table. What was the sum of total flow time? And what was the total processing time? Sum of total flow time was 409, and sum of total processing time was 110. So that's what we're going to be using. 409 over 110, which will give us 3.718. The average number of jobs in the system is 3.718. The next thing they asked us to calculate is the average job lateness. So for the average job lateness, there's something that needs to happen, which is called calculating the late days. So let's write the formula just so we don't get a bit confused. So if you remember from our formula list, which is this formula number 3, average job lateness is equal to total late days divided by number of jobs. So one thing that was not in our table was total late days, and so at this point you can redraw a table, or you can add to the one you've already drawn to add the total late days. We already have our number of jobs, so how do we add our total late days? So hopefully if you kept space on the side like I have space here, you can just rule a line, extend your already existing lines, and create late days. All right. So how you get your late days is according to our formula right here. Formula number 4 says late days is equal to flow time minus due date. That's exactly what you do. Your flow time for this was 6 and your due date was 10. So you are 4 weeks late on this. So 6 minus 10 is 4 weeks, right? 6 minus 10 is 4 weeks. However, 6 minus 10 is minus 4 weeks. However, one condition when calculating your late days is that if you get a negative number, you have to put 0, because negative numbers are not what we're looking for. So 0. 15 minus 16 is minus 1. So also what's going to be there is 0. 28 minus 6 will give you 22. It's not a negative number, so we can put the actual number there. And then we're going to go down the list and subtract our flow time, our due date from our flow time. So it is flow time minus due date equal to late days. And so here we have 43 minus 9, 34, 7, 41, 59. that's 59, 59, and then 98, and then we're going to sum it up to give us 281. And so we can now come back here, now knowing the total late days to be 281, and number of jobs stays the same as 8, and this gives us a total, this gives us 281 divided by 8, which gives us 35.125. The last thing we're asked to calculate, right, is the utilization of work center. So utilization of work center is given by total processing time divided by sum of total flow time times 100. And so the total processing time we already know from our table is 110, and the total flow time is 409. So we're going to come back here. I'm going to have equal to 110 over 409 times 100, which will give you 0.269 times 100, which will give you 26.9%. So this is basically how you solve the entire question. However, they asked us not just to do first come, first serve, which is what we've solved so far. Is first come, first serve. What we solved so far is the first come, first serve method. However, we are aware that there are several different arrangements. So I was going to solve those arrangements, but I really don't think it's necessary. If you do still have questions about how to solve those arrangements, please do send a message to a member of the academic team, Mutun, myself, Ifeanyi, and just let us know. We will do a tutorial on that if it becomes necessary. So for shortest processing time, all you have to do is rearrange your table and the numbers and details in your table, find your flow time again, like always, find your late days, and then use those in your formula to solve. It's just about rearranging the table. So with that, we have come to the end of NESA video tutorial module 1 using an assignment that we were given. If it does become necessary for me to do, I probably will still do another tutorial on the assignment model. It's something we did last semester, but most people might not be familiar with it. If you do want to see a tutorial, you can actually leave your questions in the comment section below. You can send them to me, and if you want me to still do the sequencing, which is the assignment model, let me know. I will do it. So this has been module 1. Hopefully we get module 2 and then past questions. Or at what speed do you guys want to move? Do you want us to skip the modules? Do you want us to just go straight to the past questions and do what is there? Or just let me know. So thank you for watching. Bye.